Hello everyone, my name is Mohit Bhar. I work at Salesforce as a member of technical staff. Today I'll talk about scaling Java dependency hygiene in a large monorepo using a rule called deps filter and a dependency set macro. A bit of background, I'm part of the shared repository team at Salesforce. We manage 3 monorepos for Java, Golang and Python. These repositories build over 500 plus services and 100 plus libraries. Our large effort goes towards maintaining and upgrading third-party dependencies, and often we have to deal with transitives. Now the problem statement. The core issue is hidden transitives can contaminate class path. When we declare deps, they pull in transitives, and some of them can cause trouble. For example, here declared deps are A and B. They pull in x1 and x2, both versions of same jar x. So these two different versions can conflict at runtime. There could be several issues with hidden transitives. Few of them are listed here. Like first, duplicate classes. Same class coming from multiple jars can cause runtime conflicts. Second, test versus production class path mismatch, leading to issues like works in test but fails in production. Third, security noise for the jars which are not actually being used. And fourth, extra jars in the class path. So the solution is to filter out unwanted transitives at the build time. Now Bazel is great, but there is no built-in feature to exclude transitives as provided by other build tools like Maven and Gradle. So to address this, we created a rule called deps filter. The inputs to the rule are deps, runtime deps, and exclusions. It filters out the unwanted elements and returns back a Java info provider which can be consumed by other Java targets. On the right side of the slide, we can see its usage. Filter deps is an instance of deps filter and has the exclusions, and it is referred as a dependency in the Java library target. To exclude transitives, we provide 2 ways. First is label-based. So specify the transitive you want to exclude in the deps exclude labels and optionally drop its transitives with exclude transitives by setting exclude transitives to true. Second is path-based. This is helpful for filtering out a family of jars. For example, if we specify Jackson in the deps exclude paths, then all the jars related to Jackson will be dropped. I should mention Bazel query doesn't work with deps filter because it computes exclusions at the build time. So to address that, we created another argument, verbose. If we set it to true, then we will be having the information about the jars those are dropped. Here is a simulated example of dependency graph. So here declared deps are A and G. They pull in B, E, F, C, and D transitively. With this configuration of deps filter, we are excluding B and F, but not dropping the transitives of B because exclude transitives is set to false. So once this is applied, B and F are removed from the dependency graph, and the remaining graph contains A, G, E, C, and D. If we set exclude transitives to true, then the transitives of the excluded label that are B, like the excluded labels here is B, so the transitives of B, C, and D will also be removed, and the final graph will contain A, G, and D. Now this worked well at the package level, but we wanted a shared set of exclusions to be applied for all the services. So we created a macro called Dependencyset. It's a wrapper around deps filter, plus it has shared exclusions like those can be vulnerable jars or unwanted transitives. So all the build files follow the pattern shown on the right side, that is deps, runtime deps are instance of dependency set, and once this is applied to the whole repository, then all the services will share the same set of exclusions. So before we had deps, runtime deps as lists, now we have them as an instance of dependency set. Governance model is simple, like one central team maintaining the shared exclusions, and service owners can define their own set of exclusions at the target level, and the combined outcome is better dependency hygiene at scale. So with this, we eliminated class path conflicts, speed up our security response, have a consistent dependency hygiene at scale with dependency set macro, aligned our test and production class paths, and removed the unwanted jars from the dependency graph. Adoption path is present at this link, please check it out. I would like to mention my mentors, Peter Ladd and Simon Tons. Simon is here, and by the way, this photo is from BazelCon 2018. So we are early adopters of Bazel. We have a very good experience with Bazel. We recommend it, and we only have good things to say about it. We have these open source projects present at github.com/Salesforce. Please check them out. Thank you for listening.